I've been talking a lot about circles and different lines and line segments within circles. We talked about chords, we talked about tangents, we talked about secants. So what happens is these chords, these lines, these line segments, these tangents, these secant, all these lines, they intersect. And when they intersect inside the circle, outside the circle, wherever, there's different formations and different angles are formed. What we're going to look at here is how to find the measures of angles and the relationships within these circles here. So we've done inscribed and central angles. Talking about here, inscribed and central angles are definitely things that we talked about. We talked about inscribed angles and how an inscribed angle is half of the intercepted arc and a central angle is equal to the intercepted arc. We should know that by now. Now we're going to get into angle lines that intersect inside the circle, on the circle, and outside the circle. So here are three examples. Here is intersection outside the circle, exterior. See how these are two secants, and they intersect outside the circle, and they form that angle right there. Here's two secants intersecting in the circle, okay, and they form angles right here, right? And then inscribed angle, we already know that's on the circle. That's on the circle. Okay, so there's, one goes that way, one goes that way, but they intersect right on the circle. So different types of intersections. We're going to start with angles on the circle, then we're going to go in the circle, then we're going to go outside the circle. So it's all about where do these things intersect? Where is that vertex? Where do they hit? Where do they meet? If the angles are on the circle, that means the vertex is on the circle. The vertex, that's the point where they come together. So right here, and I'm going to change colors here. Actually, I'm going to make it a little thicker. Right here, see that? How it's on the circle? All right? On the circle. On the circle. On the circle. On the circle. All these examples, the point, the vertex is on the circle. Here is the formula. It doesn't matter, it depends on what arc you're talking about. But basically, you just take half of that intercepted arcs. So if I'm talking about angle 2, see angle 2, it's on the circle, it's going to be half of that intercepted arc. There's that intercepted arc right there. It's going to be half of that. If I'm talking about angle 1, it's going to be half of this intercepted arc. It's a major arc. Okay, the other one was a minor arc. So it's going to be half of that. It's kind of like inscribed. It's kind of like inscribed, only the one leg or the one ray goes outside, or it could be a tangent. All right. Here's another one, right? So here is angle 1, and it's on the circle. So it's going to be, we're just going to follow the formula. It's just going to be half of the intercepted arc. So there's the intercepted arc. The intercepted arc is, I just wrote over it, 112. So let's write this out. The measure of angle 1 is going to equal 1/2 of 112. Half of 112 is 56. So therefore, angle 1, the measure of angle 1, that angle right there, would be 56 degrees because it's half of the intercepted arc. Why? Because the vertex is on the circle, on the circle. That's what's important in this part of the lesson. Here's another one. See this angle here? Now this angle here is not angle 1. Angle 1's over here. But this angle, I'm going to change colors. This angle right here is half of 78. See that? So half of 78 is 39. All right, so this is 39. This angle right here is 39. And then angle 1 and that are supplementary. They form that straight line there. So I'm going to do 180 minus 39, and that's going to give me 141. 141. Now another way to do that, you could have said, all right, you could have said, Well, this arc's 78, so this arc, see this right here, the rest of the circle? The rest of the circle must be 360 minus 78. Could have done it that way. And that would give you 282. So see this green, this big major green arc right here? That's 282, and then this angle's half of that. So half of 282 is 141. So either way, you're going to get 141. This one was 56, this one's 141. All right, and then this one here, now they gave me the angle. So if they give me the angle, I know the arc is double, just the opposite, right? Double the angle. So 118 times 2, and that's going to be 236. So now my arc, I'm just going to change colors. My arc is 236 degrees. That's the arc. So this arc over here is 360 minus 236. Because you know that the whole circle is 360. All right, so that's going to be 124. So x is going to be 124. So x equals 124, and y was 236. They wanted x and y there. So again, just angles half the arc's double the angle. Simple. That's whenever it's on the circle. Now, angles inside the circle. Inside the circle is these pictures here. So you got these two secants, because they go through the circle, or they could be chords. Chords or secants. Bottom line is, the angles are inside the circle. See this here? Inside the circle. When the angle's inside the circle, that's angle CED or AEB, all right? What you do is you add the two intercepted arcs, and then you divide by 2. A little confusing to look at the formula, but once you do it, I think it makes it easy. Here's a very basic one here. I'm going to get a smaller thing here. Actually, I'm going to go to purple, I think. All right. Now, here is the angle. Here's angle X. All right. Every angle inside, because see how it's an intersection? It's going to have a congruent angle. It's going to be the vertical angle is going to be congruent. So see this angle here, this purple angle here. I'm coloring it purple. And this angle here, which is angle X. Those two angles are congruent angles. Those two purple angles are equal because they're in an intersection. We already know that. The opposite angles in the intersection, they're called vertical angles, right? Vertical angles. Write that down. We have vertical angles. So because we have vertical angles, they are congruent. Measure of angle X, or as they call it, 1, was it 1 or X? X, yeah. Measure of angle X equals, let's follow the formula, it's the two intercepted arcs. So here's one intercepted arc right here, and here's the other intercepted arc right here. It's the intercepted arc for these two congruent angles. We already talked about intercepted arcs. The intercepted arcs for those angles, you add them together, 55 plus 107, and then you divide by 2. It's that simple. So the measure of angle X is going to be, I already did this, save you time, 81. Comes out to be 81. It's 162, and then divide by 2. So 81 degrees. So the measure of angle X is 81 degrees. Now here, they gave us the angle. They gave us the angle. We're trying to find the arc. Same formula though, right? So it'll be 71 degrees equals X plus 92 over 2. So same formula. But notice the difference now. They gave me the angle. I had to find the intercepted arc. I had to find one of the arcs. So I just put an X where the arc was, and I put the angle in the angle spot. Same formula. We know how to solve this. Cross multiply. 71 times 2, 142, equals X plus 92. We've solved these a million times. And then subtract 92 from both sides. And X equals, I could write it down here, I just ran out of room. X equals 50 degrees. So that arc must be 50. Now you can test it out. Does it work? 92 plus 50 is 142. Take half of that, 71. All right, you could always check it out. All right, now this one here, it wants me to find this angle, but the intercepted arcs are here and here. So with those given arcs, see they gave me 146 and 82? I think that's 82. Yeah, 82. Those arcs, I can't find angle X. I can only find these angles here, which are congruent. I could find these angles right here. So I'll call this, let me call these angles Y. I'm going to call that angle Y. I'll call them both angle Y because they're equal. They're the same thing. So angle Y, measure of angle Y, the measure of angle Y is going to be 82 plus 146 divided by 2. And that's going to be 114. So now I know angle Y, but that's not what I wanted. I wanted angle X. Well, if I know this is 114, look at this, guys. There's a straight line right here, right? Straight line, so it makes a 180. Angle X plus angle Y, X plus Y equals 180. Okay? X plus Y. If there's angles next to each other forming that straight line, they add up to 180. So I'm just going to do 180 minus 114, and I'm going to get my 66 degrees. So I know that my angle X is 66 degrees. That's because it was the supplement of 114. I knew 114 here, and then I just did the supplement. Subtract from 180, give me 66. All right, almost done here. Angles outside the circle, and there's different pictures here to show you some examples of why the angles would be outside the circle. So there's 3 scenarios. You could have 2 secants. Oh, right here, the first picture, 2 secants. You could have a secant and a tangent, or you could have 2 tangents. So the secants go through the circle. The secant, obviously, with the tangent, one's through the circle, one just touches the circle one time, and the 2 tangents each hit the circle one time each. But that doesn't matter. The bottom line, it's all the same formula. The bottom line is you have intercepted arcs. So look, I'm gonna mark the intercepted arcs. Here's 2 secants. Here's the angle outside, right? There's the angle. And here's one intercepted arc, and here's the other intercepted arc. Basically the arcs that are in between those secants. In between. So this arc here and this arc here. So darken those on your paper like I am. Those are my intercepted arcs. Here's a secant and a tangent. Again, here's my exterior angle. It's almost the same picture. Here's intercepted arc 1, and here's the other intercepted arc. It's whatever's in between, see? Whatever's in between those secant or tangents. It doesn't matter what they are. And here is the 2 tangents. Here's the exterior angle I'm talking about. And here's one intercepted arc, and here's the other intercepted arc. Now look what happens for the 2 tangents. Basically, if you add these together, it makes the entire circle. But it's 2 pieces. It gets separated, see? Still got that dot right there. Okay? So one intercepted arc here, and the other intercept is the major. So the major arc is one intercepted arc, and the minor arc on the inside is the other intercepted arc when you have 2 tangents. All right, let's do it. 3 more and we're done. This formula is almost the same, except you subtract the intercepted arcs. So we're just going to have to keep these straight. On the circle is half. Inside the circle you add. Outside the circle you subtract. I can't get my thing to stay there. All right, there we go. I'm going to switch to just a thinner purple here, back like that. All right, so I want to find angle X. Measure of angle X is going to be the intercepted arcs subtracted 93 minus 29 and divide by 2. This is a very basic example. So the measure of angle X is going to be, I did this ahead of time, 32. Basically, you just subtract the top and divide by 2. All right, here is 2 secants again. This time they give me the angle. They don't give me the intercepted arc, but that's okay. We're just going to follow the same formula. There's my one arc. There's my other arc. There's my angle, right? So angle 59. The angle equals arc 1, 168, minus arc 2. You got to do major minus minor. You got to do the bigger arc minus the smaller arc, or you're going to get a negative. You don't want a negative. X over 2. Cross multiply. So I get 118 equals 168 minus X. And then I'm going to subtract 168. That gives me negative 50 equals negative X, so therefore X is 50. So I know that this must be 50 degrees. I solve for the arc. So you can solve for the arc with the same formula. Sometimes they give you the angle, you got to find the arc. And here you got a little bit of work here. You know that all the arcs add up to 360. So if this is 183 and this is 93, I got to find Y. That's just the missing arc. All the arcs got to add up to 360. So I'm going to do 360, take away the 183, take away the 93. That's going to give me 84. So this is 84. All right, so Y equals 84. And then I'm going to find X now. So I'm going to do my formula. X equals... Now I'm doing intercepted arcs, guys. Intercepted arcs. Here's one of them, and here is the other one. There's the other. I don't care about the 93. The 93 is kind of outside. It's exterior. It's not inside. It's not intercepted. Intercepted. All right? Inside, inside. Inside that, and inside that. Got it? Inside. So it's 183 minus 84 divided by 2, and that's going to be 49.5. So angle X is 49.5 degrees. Sorry about the length of the video. Had to get this all in. It's a 2-day lesson, so we won't have a video tomorrow. I'll see you in class.